8316. A continuous loop fire detector is what of detector? A. Spot detector. B. Overheat detector. C. Rate of temperature rise detector. The correct answer is B. A continuous loop fire detector is an overheat detector. It is designed to detect excessive heat or high temperatures in a specific area or component. The continuous loop fire detection system consists of a loop of heat-sensitive wire or tubing that is installed in the area or component where overheat detection is required, such as an engine nacelle. When the temperature reaches a certain threshold or exceeds a predetermined limit, the heat-sensitive wire or tubing will detect the rise in temperature and activate an alarm or warning device. The purpose of this type of detector is to provide an early warning of potential overheating situations, allowing for appropriate actions to be taken to prevent fires or damage to the equipment. It is important to note that while a continuous loop fire detector is an effective overheat detector, it may not be designed to detect other types of fire sources, such as flames or smoke, which may require additional detection methods. 8317. What is the operating principle of the spot detector sensor in a fire detection system? A. Resistant core material that prevents current flow at normal temperatures. B. A conventional thermocouple that produces a current. C. A bimetallic thermos switch that closes when heated to a high temperature. The correct answer is C. The operating principle of a spot detector sensor in a fire detection system involves a bimetallic thermal switch that closes when heated to a high temperature. The spot detector sensor consists of two different metal strips bonded together, each with a different coefficient of thermal expansion. When exposed to heat from a fire, the temperature increases, causing the metal strips to expand at different rates. This differential expansion causes the bimetallic strip to bend or warp, resulting in the switch contacts coming into contact with each other, closing the circuit. This closure of the switch completes an electrical circuit, which can then trigger an alarm or activate other fire suppression or notification systems. This operating principle allows the spot detector sensor to detect high temperatures or excessive heat in a localized area, indicating the presence of a fire. It is a commonly used method for fire detection in various applications, including buildings, aircraft, and industrial settings. 8318. How is the fire-extinguishing agent distributed in the engine section? A. Spray nozzles and fluid pumps. B. Nitrogen pressure and slinger rings. C. Spray nozzles and perforated tubing. The correct answer is C. The fire-extinguishing agent is distributed in the engine section using spray nozzles and perforated tubing. In fire-extinguishing systems, the fire-extinguishing agent, such as fire suppressant foam or gas, is stored in containers or reservoirs. When a fire is detected or the fire-extinguishing system is activated, the agent is released and distributed throughout the engine section to suppress the fire. Spray nozzles are commonly used to disperse the fire-extinguishing agent in a fine mist or spray pattern. These nozzles are strategically positioned within the engine section to ensure optimal coverage. They provide a controlled release of the extinguishing agent to reach the desired areas affected by the fire. Perforated tubing is another method used for agent distribution. This tubing has small holes or perforations along its length, allowing the agent to be released uniformly and evenly over a larger area. The tubing is typically installed in areas where a wider coverage is desired or where it may be difficult to position individual spray nozzles. 8319. Which of the following is the safest fire-extinguishing agent to use from of toxicity and corrosion hazards? A. Bromotrifluoromethane, Halon 1202. B. Bromotrifluoromethane, Halon 1211. C. Bromotrifluoromethane, Halon 1301, Halon 1301. The correct answer is C. Halon 1202, dibromodifluoromethane, Halon 1211, bromochlorodifluoromethane, and Halon 1301, bromotrifluoromethane, are halon-based fire-extinguishing agents that have been widely used in the past due to their effectiveness in suppressing fires. However, they are now being phased out or restricted due to their negative environmental impact and safety concerns. In terms of safety from toxicity and corrosion hazards, it is generally recommended to consider alternative fire-extinguishing agents that are more environmentally friendly and have lower associated risks. For example, clean agent fire-extinguishing agents like FM 200, HFC 227EA, or Novec 1230, FK 5-1-12, are considered safer alternatives, as they are not ozone-depleting and have lower toxicity and corrosion potential. 8320. Which of the following is not used to detect ores in reciprocating engine nacelles? A. Smoke detectors. B. Rate of temperature rise detectors. C. Flame detectors. The correct answer is A. Smoke detectors are not typically used to detect fires in reciprocating engine nacelles. While smoke detectors are commonly employed in various applications to detect the presence of smoke particles, they are not specifically designed or commonly used for fire detection in reciprocating engine nacelles. In reciprocating engine nacelles, fire detection systems typically rely on other types of detectors to identify fires or potential fire conditions. Two common types of detectors used in reciprocating engine nacelles are rate of temperature rise detectors, option B, and flame detectors, option C. Rate of temperature rise detectors are designed to detect rapid increases in temperature, indicating the possibility of a fire. They are sensitive to the rate at which the temperature rises and can provide an early warning of a fire developing in the nacelle. Flame detectors, on the other hand, are designed to detect the presence of flames. They are capable of detecting the specific wavelengths of light emitted by flames and can quickly identify the presence of a fire.